Hello everyone, welcome back to my channel. And today we are going to discuss the topic of dynamic routing. In the last video, we configured static routing, and in today's video, we're going to talk about dynamic routing first. We're going to talk about some of the types of dynamic routing, and then we're going to discuss OSPF, which is part of dynamic routing, and then we're going to start configuring OSPF on our topology. So, an introduction to dynamic routing. Just like static routing, dynamic routing is a mechanism through which routers exchange routing information and adapt to changes in the network. As seen before with static routing, we had to manually tell the routers which network lied on which links. With dynamic routing, we don't have to do that. The routers will figure that out themselves. We just have to tell them that, hey, you need to start dynamic routing so that you can take part in that process. So we'll look at that. Dynamic routing can also adapt to network changes. So in case a network goes down or like a link goes down, in static routing we did floating static routes. In dynamic routing we don't need that because routers can automatically adapt to the network changes, and they can have alternate routes to the same network. So two kinds of dynamic routing. Um, the first kind is EGP, which stands for Interior Gateway Protocol, and the second kind is EGP, which stands for Exterior Gateway Protocol. Uh, there are more protocols under both of these categories. The one category that I've worked the most with is IEGP. I've worked with OSPF, which is an open standard protocol. I've worked with EGRP, which is a Cisco proprietary protocol that is very similar to OSPF. It's practically Cisco's version of OSPF. Um, there's RIP, and there's also another one, ISIS. RIP is very old dynamic routing protocol. I've seen it being barely used nowadays. There hasn't been much uses of it lately. As per EGP, the one protocol that I have used or that I've learned very little about actually, is BGP, Border Gateway Protocol. Um, in an actual network, an actual ISP to customer network, we would use BGP to connect to the IGP to the ISP. Um, or sorry, we would use some sort of EGP to connect to the ISP to have access to internet. But today's focus is OSPF, and OSPF lies under the IGP protocol. IGP. So, introduction to OSPF. OSPF stands for Open Shortest Path First. As I said before, OSPF lies under the IGP category of the dynamic routing. Um, some little facts about OSPF. Just like SDP, OSPF also holds elections to determine a DR and a BDR. It's just like in SDP, we did the root bridge. Same concept here. OSPF also holds a election to determine a designated router and a backup designated router. And I'll show how that works. We will look over some packet captures together when we start with the configuration. A DR and a BDR can be elected based on these criteria. It could First, it goes on OSPF priority. We can manually adjust OSPF priority. Next, if the OSPF priority matches between every single device, every single device participating in the OSPF network, it will go based on the highest manually added RID, the stands for router ID, and I will show you what RID is. If that is not added, if our RID has not been configured, the highest loopback interface IP will be made RID, and the election will be elected again. And if a loopback has now been set, and the loopback interface has not been set, and the highest interface IP will be used as the RID. So that's some of the ways that OSPF works. I'll show you how OSPF works in a second. Before we do that, I'll tell you guys that today we are going to first take off static routing before. So remember in the last video, we did all of those IP route commands. We're going to take those commands out, and then we'll start with dynamic routing. Then we'll add OSPF. We'll run packet capture, and I'll show you OSPF process. All right, so I will move over to GNS3 now. All right, so we're back here in our mobile XStream session, and I have my main devices that are doing the routing open here. First thing we're going to do is we're going to take off all of the routes. So basically, to take off any added route, the only one way you can do is do no IP route. Just add the part no in front of each line. That's what we're going to do. And I'm just going to add it right now. And as you can see, all right. So I'm just going to take all of this and I'm going to plug it into my site 1R1. Paste. There we go. And if we do show IP route, we should not have any static routes except this one. Okay, same thing here. No IP route. Let's copy that part. And no IP route. See if do show IP route. Do show IP route. We have all of these static routes. We want to get rid of them. And there we go. Do show IP route. And we have no static routes anymore except that one. Again, conft do show IP route. And we can see off static route that we don't want to see anymore. So we'll just add no in front. And today I don't really have a script for OSPF. I'm going to manually do it with you guys. This will also show how it works. I usually create scripts if it's very long process. Like as you seen with the static routing, it's very long. So I would generally do script for this if it's like a very long topic. OSPF generally is very easy to understand. They are you can go into depth with OSPF, which I still have to do. I have not gone too much into depth with OSPF in my own learning as well, which I should have done, but well, whatever. I'll do it soon. All right. Show IP route. And we should see no static routes anymore except the top one. Okay. All right, so now we have completely removed static routes. Now, if we were to try and pinging 888, it should work, but we should not be able to ping the other networks. Yeah, so we should not be able to ping, say, 60 dot. If we do ping 192.168, 192.168, 60.17. I think 617 is on network now. Where's 17? This is site 2, 60, 12, see, SW1 to R2. Oh, it's its own network. 60.21. IP route. SW1 to R2, SW2 to R1. Okay, all right. So to enable OSPF first, the way to do it, actually, we also want to start a packet capture. So let's first enable OSPF on this link. So I'm going to start a packet capture here, start capture, and I'll show you guys how this works. And you can see there's some going here. I'm going to filter only for only OSPF packets. OSPF. And once we run, uh, once we run or we start the OSPF process, then we'll see more logs coming in. So from R1 gig 10 to gig 00. So let's see. So to enable OSPF, the way to do it is you have to do, sorry, I just had a call. So to enable OSPF, we do router OSPF. And if you do this, you can see it will ask for a process ID. You could do whatever number you could do in this range. Uh, Generally, people, just for the demonstration purposes, I'm going to do router OSPF 1. So now I've enabled router OSPF. Let's see if anything comes up here. Nothing yet because we haven't added any interface to it. So another thing I'm going to do is I'm going to manually add the router ID. We discussed router ID during the presentation. So I've seen many people not do or not add router ID, which is fine. There's three different ways you can do this. I prefer adding a router ID to my OSPF process. So that's what I'm going to do. So to add a router ID, so just do router ID, and I'm going to give this a router ID of 4.4.4.4. And again, we don't see anything yet. Right now, I'm going to exit out of OSPF process, and I'm going to go into the interface that I'm enabling it on. So right now, I'm going to enable this on gigabit 10. So I'm going to go interface gig 10, and I'm going to say, before I say this, I'm also going to say IP OSPF priority 100. The OSPF priority is different to SCP priority. In OSPF priority, the range is from 0 to 254 or 255. The higher the range is, the more likely it is for you to be the DR and BDR. And if you want to make sure that you are never a BDR or DR, you change the priority to 0. So if I was to change the priority, if I was to make the priority here 0, this router would never become the DR or BDR. So, but I want this router to become the DR. I want this router to become the DR. So I'm going to say IP OSPF priority 100. So priority 100, and to see if there's anything popping up. Nothing yet. The other thing, well, the reason why it hasn't started showing anything here yet is because we also haven't started the router OSPF process on the other router. So, and before that, we haven't also enabled OSPF on the interface. To enable OSPF on interface gig 10, you do IP OSPF. Remember this number, IP OSPF 1 area 0. Area 0 is also known as a backbone area. A backbone area is basically where all routers have to connect to. OSPF has two different versions that we can use. We could use either a single area OSPF or a multi-area OSPF. In single area OSPF, you could have whatever area you want, but I like to keep it default to 0. There's no downside to keeping it default to 0. That's just how it is. In multi-area OSPF, you could have multiple areas, and but each area has to connect to area 0. That's the default area where every uh, DR or BDR has to connect to. So I'm keeping it area 0, IPOSPF on area 0, and as you can see, we got one hello packet, and that's basically what it is. We have enabled OSPF on this packet on this interface. So let's look at the first um, packet here. You can see OSPF hello packet, never mask 252, hello interval, router priority we added here, right? So we see we added priority 100. It says priority 100 here. It hasn't still looking for another router. So it's gonna keep saying it does not know any designated router or backup designated router. Um, so let's move on to the second one. It's gonna keep saying the same thing until it finds another router with OSPF enabled. You can also see source OSPF router with its router ID, and it says area ID backbone area. So that's what it is. So let's go ahead and enable OSPF on the second router, on the second, sorry, on the switch, on the layer 3 switch. I'm just gonna put this on the side so I know what is happening. So let's go to SW1. This was router OSPF1. OSPF1. I'm gonna give this a router ID of 2.2.2.2. Exit out of it and interface gig 00. IP OSPF priority 10 and IP OSPF 1 area 0. And as soon as I add this command, we'll see all of these other links, and you can also see that it created adjacency with 1. So let's see here. We got a hello packet from 60.13, which is SW1. As you see here, we got a source OSPF router, area ID. It says hello. Hello, is there any other OSPF router on this link? And it sees, okay, well, we have another guy. And this time, R1 replies to, as you can see, the source is R1, this destination is SW1, and it replies to SW1 with saying, hey, how are you doing? This is me. This is who I am right here. So it says itself as the designated router 60.14, and then they go through this process of some LSDB processes to exchange their databases, and it says, hey, we have all this packets here, and it becomes backup, and this hello packet you see it becomes backup designated router and active neighbor. Excuse me, 13. So now they're looking for more OSPF enabled routers on this link. I know there aren't any because they already have one. And they go through all of these states. They go through DB description, then they go to LS request, link state request. They go to LS update. Both routers will update each other on their DBs, on their databases. And then finally, they will have the acknowledgement that, hey, these are all the networks that I have. And basically, yeah. So that's basically how OSPF works. As you can see, we have a adjacency here. Once they're fully converged, they will have adjacency. to check this adjacency, we can do show IP OSPF neighbor, and you can see we have an adjacency with 4.4.4.4. So let's go ahead and add OSPF. And actually, let's also check if you do show IP OSPF. If you do show IP route OSPF, right now we haven't added any OSPF packets to the network. So to do that, well, first let's create connectivity between all the routers. So enable OSPF on this link. Now we need to enable OSPF on this link and this link, and same for both of these. So this is 3.0 and I believe 2.0. So let's go. Interface G20 IP OSPF priority 100 IP OSPF 1 area 0. Exit and G30 IP OSPF pri 100 IP OSPF 1 area IP OSPF 1 area 0. Same thing on this one. And G10 IP OSPF priority. I'm gonna do priority of 90. G10. Oh, actually, I haven't enabled OSPF here. So let's do router OSPF 1 router ID 3.3.3.3 into G10 IP OSPF priority. G10 is this one, and priority I'm gonna say 100 because I want this to be here on this link. G10 IP OSPF 1 IP OSPF 1 area 0 in G20 IP OSPF priority 90 because it is on this link. 20 is this link. So I'm gonna do 90 and I'm gonna do IP OSPF 1 area 0. And as soon as you do that, we see we became an adjacency with that. And if you were to do a do show IP OSPF neighbor, you'll see that that was also added to the neighbor table. And you can see it's in the BDR state. And int G30 IP OSPF priority 100 IP OSPF 1 area 0. And we should see another one come up here. We haven't added that interface to that yet. So let's add these interfaces as well. So on this interface, it's G01 and 01. So and G01 IP OSPF priority. I'm going to say priority 0 because I do not want this to become a DR or BDR. So IP OSPF 1 area 0. And we should see neighbor come up. There we go. And int PO1 IP OSPF priority, I'm going to say 90, and IP OSPF 1 area 0. Same thing here. LFT router OSPF 1 OSPF 1 router ID 1.1.1.1 and G00 IP OSPF priority 0 IP OSPF 1 area 0 We got one int G01, IP OSPF priority 0, IP OSPF 1 area 0, and int PO1, IP OSPF priority 90, IP OSPF 1 area 0. There we go. So do show IP OSPF neighbor, and we should see all the three routers and devices, all the three devices. So we see 2.2, 4.4, and 3.3. They're all DR on their links, on their respective links. Here we should all see as BDR and BDR. This is DR other. This is R2. Oh, sorry, not R2, SW2, switch 2, which is basically acting as a normal one because we said that, hey, this cannot be a DR or BDR, so it became the DR other, which is fine. So now we have made a OSPF ADCC with each router. So if we do show IP route, we should see some OSPF routes right here, as we see. We see 60.30 via that. 60.30, if you know 60.30 is here. So it sees, hey, this network lives on this link. It also sees 60.8, and it also sees 60.16 through OSPF. You can tell by the tags. And if you were to check with our routes before, let's compare what we have now with the routes. And let's see what we added before. So we added 60.0 before, right? And you can see we have 60.0 here. We added 60.8 before. We have 60.8 here. And we also have 60.16, 60.16 here. Where'd it go? Yeah, 60.16. We don't have the LAN interfaces yet because we haven't added. We have to manually. We'll have to manually add these to the OSPF process, and I'll do it right now. Same process over on R2. If we do show IP route OSPF, now we do this, and you can tell which ones they are. We can see 60.0, we can see 60.12 and 60.20. Same thing for SW1 and SW2. Do show IP route OSPF. Compare it to our old script, our static script. So you can see 60.4, 60.8, and 60.20. And it's going to be the same on SW2. So now we have made adjacency with everything, but R1 and R2 still do not know about the LAN interfaces. So now we have to manually go to SW1 and SW2 and tell the OSPF process that, hey, these networks also need to be advertised. So let's go ahead and do that. To do that, I'll show how to do that. So router OSPF1, we go back into the router OSPF process. And to basically add a network to advertise, the command to do that is network on an IP network. So what we're going to do, and we're going to go ahead and node network. We want to advertise 192.168, 192.168.10.0, and question mark again. You see wildcard bits, so 0.0.0.255, area 0, and that's it. And if you go to R1, and if you do show IP route again, well, it hasn't converged fully yet. Number 0.0.0.255. 1 second. Yeah. If you do clear IP OSPF process, yes. And this is going to make a GCCs again. And if you were to go ahead and do show IP OSPF neighbor, make sure we have the connectivity, and do show IP route OSPF. We see 10.0. So now we can add all of the other LANs. So same thing here, network 192.168.20.0, area 0, 30.0, 40.0, 50.0. And we should also do clear IP OSPF process. And if you were to go to do show IP OSPF, do show IP route OSPF, we should see all these links here. So let's go ahead and also do this on in here. Router OSPF1, network 192.168.10.0, 2.5 area 0, and 20. Oh, sorry, we don't need this, so we can just do no network. We don't have that network. Area 0 and 30.0, 40.0, and 50.0. So do show IP, do show IP OSPF neighbor, and we'll also see that it also created adjacency with R1 with SW1 with the VLANs. That's also fun. But now if you were to go and also do clear IP OSPF process, yes, and it's going to release everything and re-add everything. So do show IP route OSPF. As you can see, we have all these links via 12.13, 6.13, 50 sees also the 50 also sees this, 30, and it will be added later, but it's not showing right now, but it'll be added later. So we do show IP route OSPF. We see all of this. This is actually how it should look like here. And 20, 30, 40, and 50. Okay, so that's basically how OSPF works. So if you were to, from PC1, if you were to ping internet terminal, and to zoom in, if we were to ping 888, we get internet. If we do trace route 888, you'll see we have connectivity. So it goes to 10.24, 0.14, and then out to the internet. Right, so that's how OSPF works. Now we have configured working OSPF topology. We're going to just do WR, save the configurations. WR, and okay, okay, okay. That is basically it. We have now configured dynamic routing. Next step would be to create tunnels between the sites. So starting next video, we're going to configure our side routers, or other side routers, and other networks. And after that, we'll configure VPN tunnels. I'm going to use DMVPN tunnel. And after that, we'll practically have a working network, and then that will be the end of checkpoint 1. We'll move on to checkpoint 2, which is the Windows server. So Thank you guys for watching. I'll see you guys then.